All right. Good evening, everyone. Thank you so much for joining us for another session of StackLeague Tech Sessions. And this time we are partnered with AWS or Amazon Web Services. And we have here a very special guest who is very supportive of all different tech initiatives here in the country. So first, let me just give you an overview of what Stack League is. So if this is the first time that you have joined a Stack League session, welcome. So I will just give you a quick introduction of what Stack League is. So Stack League is the Philippines' first year-round programming tournament. We launched last March 16, and by now we already have over 4,000 programmers in the league nationwide who are competing not just for the following. For we have the cash prize pool of 300,000 and continues to increase. We also have national recognition thanks to our media partners. We have thousands of giveaways. And of course, we also have tech job opportunities. So this is very relevant, especially if you are currently looking for job opportunities today or in the future. And of course, exclusive exclusive events. So it could be about upskilling like your tech skills, or it could be about careers to help you look for the opportunities that is right for you. And here is how we do this, the ranking system in the league. Think of it as a game wherein when you start at the bottom with 0 points. Your goal is to have as much points as you can. And we have 3 levels. So the first one is bronze, wherein the questions are these are the types of easy questions that you can solve. And then when you reach a certain level of rank, you reach a certain number of points, then you level up to silver, and then you level up to gold. So gold questions are the hardest ones, but it provides you the most number of points. So think of it as the hardest monsters in a game. There you go. So every level has their own set of opportunities, set of access, and set of reputation. So here, for example, we have right now an opportunity for Stack League Pro. And Stack League Pro is only accessible to gold level participants. So there you go. And what are the different programming languages for Stack League? So these are the 5. We have JavaScript, Java, Python, C Sharp, and PHP. And of course, if the purpose of the league is that at the end of the year we get to identify the top 10 developers here in the country, on a weekly basis, we also identify the top 10. So who are the ones who has the most number of points in the league itself. So each of them, if you reach the top 10, you get to have 500 pesos cash prize. And that's it. So that's an overview of Stack League. Now, I introduce to you our speaker for tonight. So everyone, help me welcome the Senior Solutions Architect of Amazon Web Services, Mr. Rom Gapuz Jr. Rom?
Hi, Haifa. Thank you. Yeah, so thank you, everyone. Thank you for inviting me. It's been a pleasure to be here. I'm excited to talk to you about how to host your apps on the cloud. So, as mentioned by Haifa, I am Rom Gapuz. I am a solutions architect for AWS Philippines. I've been with AWS for more than 4 years now. And what I do is I help customers bring their apps on the AWS cloud in an efficient, cost effective, and secure way. So after this talk, if you have anything for me, feel free to reach me out via LinkedIn. So the link of my profile is down below there on your screen. If you have any questions, feel free to comment it. Hopefully, we could run through it over our session so that I can answer some of the questions that you might have. So let's jump right into our topic for tonight. So for tonight, we're going to talk about how to host your apps on the cloud, specifically the AWS cloud, and how you can leverage the power of the AWS cloud to run your apps. We'll run through the different options of hosting your app on AWS, and this is not a comprehensive list, but I'll show you the most common options of hosting your applications on AWS. Here's our agenda for today. So I'll do an introduction of AWS. This is for the benefit of those who are not familiar with AWS. If you are, that's great. What would benefit you is the hosting options and the cloud architecture journey. This is a level 100 to 200 talk, as we call it, meaning it's introductory to intermediate talk. We won't dive deep, but if you have specific questions, please do write that down in the comments, and I'll try to answer as much as I can. And if you have further inquiries, you can reach me out to via LinkedIn, as I mentioned a while ago. Okay. So let's talk about introduction to AWS first. So AWS stands for Amazon Web Services. So our parent company, as you are familiar, is Amazon, which is the retail company, Amazon.com. AWS is the cloud computing platform provider that is under Amazon. So this is what runs Amazon.com under the hood. So Amazon.com runs on top of AWS. So um, it was established in 2006 out of the need of what we call web services back then. And now it's commonly called cloud computing. So, what sets AWS apart? So, number one is the security and compliance. So, we'll run through this list as we go along. So, security and compliance is one, and one of the most important of the list is security. So, we bake security in each and every services that we have. Next is the breadth and depth of the services that we have. We have 200 plus fully featured services that can support any type of workload. I'll just cover very few of them. Tonight it's impossible to cover all 200 plus, but I'll try to cover just a few of them. If you have any questions, just feel free to do that in the chat. And AWS has the most experience. I mentioned, we've been in the business of cloud computing since 2006, back in the days that we just call it web services. We don't call it cloud computing. We have global reach and high availability. So we have this concept of availability zone. I'll go through that later on. And then we have 25 geographic regions. A region is essentially a location where you can get AWS services. So that an example is Singapore, Hong Kong, Japan, Sydney. Those are some of those closer to the Philippines. And then you can improve your TCO. So this uncommon business practice, which is reducing your price. And we've been doing this since 2006. So we have 107 proactive price reduction to date. When we say proactive, this is not driven by our customers. It's actually driven a decision of AWS out of um, the what we call the economies of scale that we have. So the more customers uses AWS cloud, the more that we can reduce our costs, and we pass those cost savings down to our customers. We have the largest community of customers and partners. We have thousands of consulting and ISV partners that provides solutions and consulting services to our customers. It Most of those partners and that we have are outside the United States, as you um, can see on the screen. And lastly, is we are the enterprise leader. So when you look at the enterprise, AWS was first and still popular with the startup community. It's when you have a startup, it's common that they usually pick AWS to run their workload, and we still are. But aside from that, we are also the enterprise leader. So even enterprise companies are looking at AWS to run their core critical workload. Okay, so let's talk about security and compliance. So in terms of security and compliance, this is the most important thing for AWS. So this is baked in each and every services that we have, and we have hundreds of standards and compliance certifications. So these are just some of those: PCI DSS, HIPAA. So PCI DSS if you want to process credit card transaction, HIPAA, high tech if you are in healthcare. So GDPR for data privacy and a lot more. So we basically have our services audit so that we can attain these certifications, and this basically gives confidence to our customers that the underlying platform where they run their applications are are audited and have this compliance certification. So in a way, it's much easier for you to attain this certification, because what you just need to do is have your underlying applications, the underlying infrastructure is already has already this certification. So the applications, that's just the one that you need to certify with this compliance. And um, um, we have 117 AWS services that allows you to store data. Basically, all services that allows you to store data, there is an ability to encrypt that data. And we offer the highest encryption standard that is available in the industry right now. So the same standard that top secret government use for their top secret classification of data. In terms of breadth and services and depth of services, as I mentioned, we have 200 plus services, and depending on the workload that you're looking at, we have an offering on those. So you have analytics, databases, hybrid architectures that allows you to connect your on-premise infrastructure going to AWS. We have Internet of Things, IoT. If you have IoT devices, if you want to connect to the cloud, we have development tools that allows you to have a create a CI/CD pipeline, business applications, blockchain. If you're into that space in the fintech, and security, identity, and compliance. That's as I mentioned, the most important part of the AWS services is security. So we have a lot of services under that. Storage. So we have virtually unlimited storage that is available for you. We have compute services where you used to run your application on top. And we'll talk more about this as we go along in this session. We have media services. So if you want to do, for example, video streaming as what we're doing right now, you can create such service using the AWS cloud. And you have the machine learning. So if you want to create machine learning model, you can do that. Or if you just want to utilize an existing AI services, we have that. So it's AI services such as chatbot, face detection, forecasting, speech to text or text to speech. So there's a lot of different AI services that is available on AWS. So in terms of pace of innovation, as you can see here, this is a graph of the different the number of significant services and features that we launched on that year. So in 2011, we've launched 80, and then the next year 160 to 80. So as you move along, last 2020, we were able to launch 2,757 services, significant services and features, and this keeps on growing. So you can see the scale that AWS, in terms of shipping out new services and features to our customers. And you can drive this. So what we say in AWS is that 90% of our services and features are actually directly influenced by our customers. This is through our conversation with customers, and we have this mechanism that allows you to give us feedback, and we push it down to our what we call the service team that looks at it and prioritize depending on the our market asks. So if you ask for a specific feature, you can do that, and 90% of the time that goes to this list. and 90% of the features are driven by our customers. And the remaining 10% is how we interpret what our customer needs in terms of services and features. So ultimately, 100% of our products and services are driven by our customers. This another thing that sets AWS apart is our experience and operational reliability. So we have millions of active customers that uses AWS, and um, even though we have that much of customers, we are still the most reliable, secure, scalable, and cost-effective infrastructure that is available. So we've been doing this for more than a decade. So this is since 2006. And we have this concept of availability zone, which is an isolated fault lines, floodplains, networks, and electrical grids. This allows you to have redundancy of the underlying infrastructure. I'll go more into that as I talk about the global infrastructure, which is on the next slide. So this is our global infrastructure. So you can see the dots there are basically what we call the regions. So the blue dots are regions that are existing right now, and we plan to launch some regions which are in orange colors. Those are announced region that we're gonna launch soon. So as you can see, um, this is Indonesia. So we're planning to launch a new region in Indonesia. So a region is a location where you can get our services, the cloud services, and within that region we have at least three availability zone. So as I mentioned, an availability zone allows for redundancy. So this is how it looks like. So for example, if we zoom in into North Virginia, in North Virginia, let's say here we have six availability zone. So this is the whole region in North Virginia, USA. We have six availability zone. So one of these boxes is an availability zone, and each of those boxes is a cluster of data center. So by itself, an availability zone is redundant because it's a cluster of data center, and so um, and a region is a cluster of availability zone. So, for example, we have a service called Amazon S3, which is an object storage. So you can store any type of files that you have, and it's a regional service. So whenever you store an object, a file on Amazon S3, it gets replicated across multiple availability zone. So even if one availability zone goes down, since it's replicated across multiple availability zone, your data is still available, and you achieve the durability. Actually, Amazon S3 has 11 nines of durability. That's 99.9999 up to 11 nines of durability. And what that means is if you have 10,000 files on 10 million files on S3, the tendency of you losing a file is within 10,000 years. So that's how durable S3 is. And that's because of the design of our regions. And as you can see, we have multiple availability zone. And our minimum number of availability zone is three. So you can see here, we have regions like Sydney who has three availability zone. If I can just find Singapore, it's here, Singapore, which is on the lower right. You can see here, Singapore has three availability zones. So that's the minimum number of availability zones that we build. So as new regions launch, like for example, Indonesia, when that launches, it will have three availability zones. That is to provide redundancy for our services. So if you use our service by itself, it is redundant to failure. And I mentioned this, we have large community of customers and partners. And so you can look at communities. We have here, um, we have a local community here in the Philippines, AWS User Group Philippines, that is a community that talks about AWS technologies. So you can get help from there. We also have partners that you can leverage to uh, for consulting or utilize their products. And we have AWS Marketplace that you can just search for a particular solution and just deploy it on your AWS account. So let's talk about the enterprise leadership of AWS. So we've been acknowledged by different um, body analysts in the industry. So this is Gartner that creates a magic quadrant. So we've been the cloud leader for 10 consecutive years. And they positioned us as the leader in the magic quadrant, as you can see there. In terms of completeness of vision and ability to execute, we are the highest. You can learn more about this by going through that QR code. Another one that recognizes us is IDC, and it's saying that AWS has the most capability and most strategic in terms of the cloud service that we offer. Another thing is Forrester that acknowledge AWS leadership in terms of uh, containers, which is container platforms, which is another technology that we'll talk about. So we have virtual machine containerization and then serverless. So this Forrester that is acknowledging us in the containerization. So that's it for the intro for AWS. Let's move on to the core of our talk for tonight. So let's talk about first the different hosting options that is available for you when you want to host your application on AWS Cloud. As I mentioned, this is not the full list. Um, so I'll jump right into it. So we have virtual machine, container, and serverless. So I'll focus more on this as this is the most common. But there are other applications that is available. For example, if you want to create games, we have a different service for that. If you want to create IoT applications, we have a different service for that. Machine learning, analytics, those are different applications that is available. So what I'll present here are applications mainly because in terms of the audience that we have, as I heard, is mostly developers. In StackLeague is there are mostly developers here. So these are hosting options for developers who are creating applications using code. So we have here the virtual machine and then container and then serverless. So when we say virtual machine, this is um, not a physical, a virtual server that you can host your applications on top. So you can select different operating system, etc. When you say container, this is another abstraction on top of a virtual machine. So inside a server, a virtual machine, you can create containers inside it. You can host multiple containers, and then we have serverless, which is you don't need to manage the underlying servers. We call it serverless in a sense that you don't need to manage the server. Of course, there is a server behind it, but the management of that is provided by AWS, so you don't need to manage it. As opposed to virtual machine, where you fully manage the server, it's totally 100% your control. The containers is there is a mix. You can fully manage the server, or you can have some of it managed by AWS and some of it is managed by you, and you can have a container that is fully managed by AWS. So we have different options on that. So we'll talk more about that as we go along. Okay, so let's talk about the virtual machine. We have a service called Amazon EC2. So EC2 stands for Elastic Compute Cloud. So it's essentially a virtual machine, a server. So if you want to host your application, you would normally get a server, install any component. So for example, if I want to host a web application built on, for example, a Node.js application, what I would do is I would create a server, install the necessary components, the web server, the libraries for Node.js, and including my code. I upload my code, and then I host it, and then it's available on the internet. So that's a virtual machine where you have full control of the server. So we have a lot of different options here. So you have a lot of choices. So we have different categories: general purpose, first of all, compute intensive, memory intensive. So depending on the type of application that you're running, if it's more computational, you utilize compute intensive EC2 instances. If there's a lot of memory that is required, maybe there's a lot of um, yeah, you would need a memory intensive application. If there is a lot of storage, this IO that you need, you would go for storage. Uh, um, Storage category. If you have more data that you want, you have dense storage. If you want an option for GPU, this is the graphics processing unit. So applications like games or rendering videos, or machine learning, you can utilize the GPU for that. And graphics intensive, so that's another choice. So in terms of capability, you have the choice of different processor. So you have AWS. We have our own processor. We call it Graviton, and it's based on the ARM processor. You have the Intel, and then you have the AMD. And there's also other options that is available that is not on the list. Up to 4 gigahertz fast processor, high memory footprint. So you can create a virtual machine that has 12 terabytes uh, of up to around 12 terabytes of memory. And then instant storage, you can select from a hard disk or a solid state drive. Yeah. Yeah. Other type of computing, GPU or field programmable gate array. Networking up to 100 gigabit per second per instance. That's per instance. And you also have an available for bare metal if you want the raw performance. And then the sizing, this increase the CPU and RAM that is available for the instance. So as you grow it, the more CPU and RAM. So you can grow as large as 32x large. And then options for other options like these for storage, and elastic inference is for machine learning. So we have 300 plus instance types that is available for the different computing needs that you may have. So as I mentioned, we have Intel, AMD, and then Graviton, which is based on the ARM architecture. I forgot to mention we also have Mac. So if you are developing applications for Mac, you would need a Mac for that, right? So instead of uh, having a machine, a Mac that is used for development environment, and I've seen that for some of the customers, they have this machine fleet of Mac um, computers that is used for development purposes. You don't need to have that. You can just use a Mac instance from AWS, so you can turn it on and off depending on the need that you have. Yeah, broad set of accelerator in terms of I guess machine learning is the most common use case for the GPU. So you have NVIDIA and AWS Inferentia. This is for inference, machine learning inference. It's a processor that is uh, purposely built for machine learning inference. Yeah. So there's so much about virtual machine, Amazon EC2 per se, but I'm not able to cover. I cannot cover all of the things that is in there. If you have any questions, feel free to comment those. So let's talk about container. So container is we have services like ECS, EKS, and Fargate. I'll talk about that later on. So when you say ECS, we this is the Amazon Elastic Container Services. EKS is Amazon Elastic Container Services for Kubernetes. So we have this is an orchestration. So this orchestrate the deployment of your container. So depending on the type of what you want in terms of orchestration, so popular or open source orchestration is Kubernetes. So you can utilize Kubernetes for that. If you have not done Kubernetes and you just want plain simple orchestration services, you would go for ECS, which is a native orchestration, container orchestration tool of AWS. For hosting your application, you have I mentioned about EC2. So for for hosting your container, you can put it on EC2 that you manage, or you can have it fully managed by AWS by hosting it in AWS Fargate. So this is a serverless offering of containers where you can host your container in a serverless fashion. So you don't think about the servers. You just push the container into Fargate and let AWS manage the underlying servers to run your container. And of course, for container, for it needs to be loaded first in a registry. So we have Docker Hub, which is a popular repository for container. So we also have that, which is Amazon Elastic Container Registry, or ECR, that allows you to upload the images of your container so that you can pull it into either ECS or EKS for deployment of your containers. So this is how it looks like in a high level overview. So you have your orchestration on top. This allows the scheduling on orchestration of your container. So the cluster, which are EC2 instances, the virtual machine, and the container are deployed inside those EC2 machine. So the orchestration service, the ECS or EKS, is the one that will decide on those for you. So you don't need to manage that heavy lifting. So the orchestration service will do that for you. And I mentioned this Fargate, which is managed by AWS. You don't need to think about the servers. So in a way, it's a combination. It's a hybrid of containerization and serverless. So it's a container that is serverless. So we'll talk about serverless later on. So, but this is a hybrid of those two, in which you just push your container into Fargate, and AWS will manage the underlying server for Fargate. You don't need to think about it. We will just run your container. And this is available for either ECS, Elastic Container Services, and EKS, Elastic Kubernetes Services. And just a trivia, 51% of Kubernetes workload that is available runs on AWS as per CNCF survey. So this is how it looks like in if you want to use Kubernetes, Elastic Kubernetes Services. So you would use your familiar tool, the kubectl. You just issue kubectl commands against your EKS cluster. That's the endpoint. It varies depending on the endpoint that you create, and it will be the one that orchestrate the deployment of your containers. So lastly, let's talk about serverless. So serverless is a concept. It's not a it's not a service. So there's a lot of different services around serverless. So when we talk about serverless, the concept is that there's no server for you to manage. It's fully managed by AWS, and that's serverless. I mentioned Amazon S3 a while ago, in which you can use this for object storage. It has virtually unlimited storage capacity, and this is serverless in nature, in which you don't manage the server, you just use the service. Let's Much like how you would use software as a service, as SaaS. You just use the service, and you don't think about how to manage the underlying infrastructure, the servers, the networking, all of those things. You don't need to think about that. You just want it to do its thing. So one common example for compute, which is running your application for serverless, is AWS Lambda. And this basically revolutionized the concept of serverless. AWS Lambda is basically a function that you can give to AWS, and we will run it for you. So there's no infrastructure for you to provision or manage. That's why it's serverless. It automatically scale. So the management part, scaling it, is passed on to AWS. You don't need to think about that. So you pay for the value of using the serverless. So in AWS Lambda, that one, once it runs, you pay for the amount of time when it runs. If it's not running, you don't need to pay for it. There's no payment for when it's not running. So that's essentially one of the common attribute of a serverless service. It's highly available and secure as this is fully managed by AWS. So it's an operational model. It's a concept, as I mentioned. It's not a service or a specific service of AWS. So you can see here when we talk about compute, you have here the AWS Lambda, which is a function that that AWS runs for you. It's a function. It's a piece of code. AWS Fargate is a container that AWS runs for you in a serverless fashion. And in terms of data storage, I mentioned S3. That's a serverless. Amazon Aurora serverless, which is a relational database management system, RDBMS type of database like MySQL, PostgreSQL, that you can run in a serverless fashion. Amazon DynamoDB is a no SQL type of database, so it's not no it's not an SQL type of database like document database, key value pair, key value database. So that's an example of a NoSQL database. And Amazon DynamoDB is a serverless database. In terms of integration, for API, you have API Gateway, SQS, which is queuing technology, SNS, notification service, which is for messaging, step function to orchestrate different steps in a serverless um, uh, workflow. You have AppSync to that exposes GraphQL, and these are just some of the examples. So there's a lot of different services of AWS that has a serverless attribute. So we've talked about the virtual machine, the container, and the serverless. So as you can see here, we you can see here the operational responsibility whenever you use a particular type of either virtual machine, container, or serverless. So if you want to use serverless, there's less for you to manage. So the operational reliability is less. So as you go more to the right, there's less operational responsibility. As you go towards the left, which is you have here the virtual machine, the database that you install on top of a virtual machine. You have um, more responsibility on that. So, and yeah, yeah. So you have different options on compute, database storage, messaging, analytics, and a lot more for in terms of the operational reliability. So as you move towards left or right, the responsibility changes. Okay. So once now we have an understanding of AWS, we also talk about the different options of hosting your application on AWS. Now let's talk about the typical journey of hosting an application on AWS. So let's look at the story of Amazon.com. So Amazon.com in 1994 they started out as a monolithic architecture, and that's how most majority of the application starts with. And in 2001 is still a monolithic architecture, and it has grown so big, and it's managed by a lot of developers, hundreds or if not thousands of developers managing the code base. And it gets, as it grows, it becomes hard to manage. So that's why we started to rethink how we approach this um, development concept. So we have a transformation in 2002. So we use a combination of technology and also processes to do this. So we decouple the services, and we also have the concept of two pizza team. We'll go more on that. So in terms of technology, we broke it down into microservices. So essentially, a microservices is a way to decentralize the components into reusable modules of code. So we just dice it up into a functional piece of code or service as we call it. So it's independent of its of the other, although it has dependency. In terms of dependency, they maintain an API contract in terms of dependency when they talk to each other. And by itself, it has its own, it runs its own logic, and it has its own SLA, and it's managed by a single team. So um, in terms of transformation that we've done, we will align this to the concept of Amazon DevOps. So this concept is, number one is breaking things down, which is people. So we'll talk about people, process, and technology. When we talk about people, is that's number two, which is teams are autonomous and businesses, autonomous businesses. And in terms of process, that is breaking things down. So we are making the process smaller for an autonomous team. And then in terms of technology, we apply it across everything that we can automate it. So let's talk about breaking things down. So Martin Fowler is a computer scientist, and he visited Australia, particularly in Queensland, Australia, and saw this massive, majestic tree. And as you can see here, there's like vines that is clinging on the tree, and that is what we call the strangler fig. So that's a type of plant that basically hugs the tree, which is the tree is the host. So it hugs the tree and basically strangle it. That's why it's called strangler fig. It strangles it, sinasakal, and until the host tree dies. So that's what happened. And so the strangler fig grows by killing the host tree, as you can see. And he used this metaphor to create the strangler pattern. The strangler pattern is a way to basically break down a monolithic application. So as you can, as I mentioned a while ago, it really started out as a monolithic architecture, and we moved on to microservices. So we utilize the concept of distributed computing and also the strangler pattern to basically break down the monolith. So if you look at this, this is a monolithic application. This is a web application. So you have a monolith app and the database sitting on one, maybe one server, and you have the browser, which is the client that is using the application. Now, if we want to break it down, we can uh, take a piece of it and make it as a service with its own database. And the browser would just talk to this both monolith, the monolith, and the service. And as we further do that, we are breaking down the monolith into multiple services up until there's no more monolith. We can decommission the monolith. So this is a way for you to move to a monolith to microservices. And this is a journey. There are some there is a benefit of starting out with a monolith because you wanted to start fast. You want a go to market, so you started out in a monolith, and then as your business grow, there is a need to decouple it into multiple microservices. So this is a approach that you can take to break down the monolith where you started and break it down to microservices as your business grow. And another concept of a microservices is that events are observable, not directed. So when you say, for example, in an invoice, if there is a command, okay, Joe, create an invoice. So that's a command pattern. So when the invoice is created and then the application where the command is passed is creates it. Now, if there are dependency in that invoice, so what you would normally do, for example, if I create an invoice, I would go to accounting. Hey, this here's the invoice, and I guess I go to sales. Hey, this is a copy of invoice, and I'll go to a different department that would need that invoice. So that is directed, and that's not efficient. That's not efficient if we um, compare it into a microservices. Now, the idea is to convert that into events. So if I create an invoice, it's just that I'm just announcing, hey, I created an invoice. And whoever are listening, observing that particular event can act if that particular event triggers. So, for example, if I create an invoice, there can be someone in the finance department that is listening. And if they see the invoice, hey, the invoice is created, so I'll do this. If someone from sales sees that, then they'll do this. If someone from warehousing sees the invoice being created, they will do something. So it is there an event triggers multiple action that are observed by different observers. So that's the one of the concept of making it microservices is making events observable instead of directed, so that you can scale to more um, users for your application. And then let's talk about teams. So I mentioned this. We have this concept of two pizza team. It's essentially a very small team. Why two pizza? Because we can feed that team with two pizzas. So there is a metaphor for that. Um, so it's not that big and not that small. So they can finish the two pizza. So it's not that big that that two pizza is not enough for the whole team. So it's around 5 to 10 people, depending on depending on the service that they own. So it's a small decentralized teams that are nimble, agile, and they own what they build. So when you build it, you run it, and then you own it. You maintain it once it's running. So if there is something broken, the responsible is that team. You don't have this separation of you have the builder, and then you have the operations, where someone builds it and someone operates it. No, it's a combination. So all of those functional people that comprises of the total life cycle of an application is in that team. So you have the developers, the product manager, you have the administrator, the analyst, all of those people is in that single team, and that two pizza team. Yeah. So if we talk about DevOps, we have these three ways, yeah, that you can adopt. You would start with a common a common structure, organizational structure for building applications is the one on the left. So this is traditional. So you would see here the one who builds, which is the engineering, builds it and then pass it on to operations, the one that operates it. And there is a difference also when the one building it and the one that is managing the cloud infrastructure. So there is the one that is building the cloud infrastructure on the lower left, and the one operating, managing the cloud infrastructure. So there are four teams, as you can see here, for just one application. And then as we move to the right, on the center, we have this a more optimized, the, utilizing the concept of DevOps. So the one that is building is one team with the one that is maintaining it, operating it. So as you can see, for the application, it's application engineering. The engineering building it and operating it is just one team. As well as for the platform, which is using cloud, it's just one team. The one building the cloud infrastructure is also the one that is managing it. Now, the the holy grail here, the one that we want to achieve is this one, a decentralized DevOps, in which that one team is basically in charge of the application, both the application and the platform, for building it and operating it on the cloud. And then you may have this cloud platform engineering team, which is a different team that provides best practices across different teams that you may have. So this is one approach that you can adopt. Yeah. So a two pizza team is not functional. So as you can see here, these are different function: QA, operations, application security, administrators, etc. And there are separated teams. So when the software development is done, they pass it on to the administrator to manage it, etc., and operation. So they have their own function. Whereas in a DevOps paradigm, they are working together. All the functions is in one team, and they own what they build. So those are the three. Um, so the third is to automate. So this is around technology. So we have the developer tools in AWS that you can utilize to do DevOps. So you have from authoring it, you have a cloud IDE, which is Cloud9, and then you have for your source code when you're building it, testing it, and then when you deploy it, there are different services. And this is just an example. And then you have code pipeline that ties them all together so you can create workflow for your CI/CD pipeline. And then you have monitoring tools. And you have a way here to model the infrastructure that you have, including your application in a software as a code, or infrastructure as a code. So through CloudFormation, CDK, and SAM. So this is an example of a CI/CD pipeline. So as a developer, you would use an IDE. It can be your own machine or it can be a cloud IDE. So you develop your applications and then you commit it to a source code repository. So an example of that is code commit. And once that happens, it will trigger the CI/CD pipeline. So a code pipeline will detect that, trigger it, and then build it, and then store the artifact, and then use code deploy to deploy it. And then you have here on the right, this is your application deployed by just pushing a code on code commit. So this is fully automated for you. If you're interested to know more, you can visit these links like the DevOps workshop if you want to know more how you can create the CI/CD pipeline. And this is another workshop that we have. And for specific services, you can go to this link. And there's a lot more videos on YouTube that is available. Just search for these keywords. So that's it for me. So to summarize, we talked about an introduction with AWS, and then afterwards, we talked about the different hosting options on AWS that is available for your applications, the virtual machine, the containerization, the serverless. And then lastly, we talked about the cloud journey. Essentially, we focus on a microservices approach as well um, as CI/CD, which is the technology, and and process, people, and technology. So if you have any questions, feel free to chat it in the comments, and I'm available in LinkedIn. You can connect to me, and if you have any questions, just reach out to me. Thank you. I'll pass it on to the host, Haifa. Thank you.
All right. Thank you so much, Rom, for your very intensive talk on cloud. I do have a question, Rom. So a lot of our participants here are students. What what are your suggestions on how they can start? Let's say they're still graduating students and they want to explore cloud while they're still in school. What are your
Mhm.
suggestions for them to start?
Yeah, yeah. So I have a couple of suggestions for students. So we do have a program. It's called AWS Educate. So AWS Educate is a program for students. So you can register here. You can get your AWS account and you can start playing around the AWS services, the technology that is available for this. This is a program that is available for students. So this is one, and then the other one is AWS has this free tier, which is free use of these services depending on the terms that is available. So you have, for different services that we have different options for free tier. For example, the virtual machine, you have 750 hours of free per month for a T2 micro, that's the size, and T3 micro for Linux, RHEL, and SLS operating system. So you can go to aws.amazon.com/free. You can see the free tier that is available. For AWS Educate, the link is aws.amazon.com/education/AWS Educate.
All right, sige, thank you so much, Rom. So we have it there for students. There is a free tool for you to use using AWS Educate. So we have one question here from Casey Kalunod. So good evening po. What is the differentiator of AWS versus Azure or
Mhm.
GCP?
Yeah. So I did mention what sets AWS apart, although I did not mention any other cloud providers, but I did mention about what sets AWS apart in my introduction to AWS. So there's a lot of different points that I tackled there. So you have security and compliance. We have the most comprehensive in terms of security and compliance. We have the most compliances attestation that is available. Um, I guess I can share that. Yeah. We have the most compliance and attestation that is available on any cloud provider. And we have, in terms of breadth and depth of services, we have the breadth and we have the depth, which is the features, is fully featured services. And we have 200 plus of those fully featured services. And next is we have the most experience. We've been here since 2006. The next cloud service provider that launched is after 7 years. So that's the next one. So we had a head start of 7 years. So in terms of experience, we have the most experience, and that's why it goes back to our operational reliability. That's why we are more reliable. We have more global reach, and we are highly available because our operational reliability is higher because we have the most experience. Aside from that is our costing structure. We try to lower the price. Contrary to common business practice, we actually lower the price, and we have 107 proactive price reduction since our inception in 2006. And we have the largest community of customers and partners. So you can think about Airbnb, Pinterest, Netflix. So, and there's a lot here also in the Philippines that is using AWS, Union Bank, Globe, who are running on top of AWS. So we have the largest community of customers and also partners that can help you on your cloud journey. And we have analysts in the industry like Gartner, IDC, Forrester, who position AWS as the enterprise leader. Yeah. So that's my long answer on that question.
All right, thanks, Rom. Hopefully, Casey, Rom was able to answer your question. Essentially, AWS is really the leading cloud provider. So there are a lot of charts that really sets AWS apart. And security and compliance is really the a lot of the enterprise companies really go to AWS, especially for security and compliance. One of them, mainly banking industry, are is really reliant on AWS for their applications as well. Okay,
That's
so
true.
yes.
Yeah, just to add, since you mentioned
Mm,
about security, the same security services that the largest enterprise uses, you have that available for you when you create your AWS account. It's the same security. For example, the encryption standard AES 256 encryption that is available for you, and that's just a checkbox on your AWS account. So when you create a storage, you want encryption. That's the same encryption standard for top secret files of governments, and that is available for you. Encryption available for you. Usually, there's no cost on the encryption.
okay, sige. So, next question we have from AI Rudio. Is AWS subscription based?
Mhm. Yes. A lot of AWS services, the concept of cloud is pay as you go. So, yes, it's subscription. So you pay when you use it. If you don't use it, yeah, you don't pay for it. So it's much like our utility, electricity, water. So when you're using it, you pay for it. When you're not using it, there's nothing to pay. So yes.
Okay. Is there any other, well, apart from, oh, this is my follow-up question na lang, Rom, no? So it's subscription-based, but for example, are there other models apart from subscription, or everything that AWS offers right now is subscription-based?
Yes, majority is subscription. There are services that I can say that are not subscription, maybe based on the number. For example, if you want to do block level replication from one server to another, we have a service called Cloud Endure. If you want to create a disaster recovery, and that is per server. So in a way, it's still a subscription because it's per use. So in a way, it's still subscription, but it's not a subscription in which yeah we don't use subscription in AWS. That's why it's a bit hard to use that term. We don't use that term. We use pay as you go. It's can be per month, per hour, per server. So it's per use.
Got it. So
Mhm.
essentially, there is a specific quantity that they pay, and
Unit, yeah.
then yeah, there is a certain unit. So it's
Mhm.
not exactly subscription. Okay, sige. I think we have no more questions here. Let me just double check. Hmm. Yep, there's none. I think that's the last question, Ram. So thank you so much again, Ram, for your time. Is there any last words that you'd like to share with our participants for tonight?
Yes, thank you for joining us. And do hit me up on LinkedIn, connect with me. So just search my name, Rom Gapuz. You can find me on LinkedIn. Just connect with me and I'll accept it. If you have
Uh,
any further questions, just reach out to me. Thank you. And thank you
uh,
for StackLeague, for Haifa, for inviting me to talk here. It's been a pleasure.
all right. Thank you so much again, everyone, for joining us tonight. And we hope to see you on the next session. By the way, we have another session next week. So that would be with AWS as well. And we will be talking about serverless and containers. Some of them Rom already mentioned on this session. So you already have a basic overview. But if you want to learn more, that would be for the next session next week. That's it. Thank you so much, everyone, and good night. Thanks, Rom.
Thank you.